Okay, so before I teach you the last ever thing, I'll tell you what we're going to do. We're going to take a break in about 5 minutes, okay? I guess what I just want to do at the moment is kind of give an indication of where matrices are useful. So if you remember, I gave you this sheet. I've already, where I started with matrices, I already said this is where matrices are useful. They're just a table of numbers, okay? So for example, the first context is number of sandwiches sold in a school canteen versus the cost, okay? Then I could use that to try and find, my whatever matrix multiplication I needed to do, okay? But I want to give you another real-world application of matrices that I think is actually quite useful. And it's to do with Google, okay? So we're all familiar with Google, right? Yeah? It's like the search engine on the internet, okay? Really powerful search engine. But Google, baked into the heart of it, is a matrix, okay? Now, I'm not going to go into all of the definitions of how Google works, because actually there's lots of operations, okay? But what I'm going to do is give like an overview, like an insight, a bit of inspiration for how Google may use matrices, okay? So, what is the primary function of Google? I realize it's a big company now, it does lots of things, but what was the primary function of Google way back in the 90s? It's a search engine, right? So basically the idea is you have a search bar, you type your search query in there, and then it will return you a series of web pages that it thinks is relevant to that search theory, okay? So how does it know what are the most useful search pages to return? That's my question. Now, what I want you to do is I want you to think about each web page on the internet as a dot. Okay, so I'm just going to draw 3 dots on the internet on my board. Okay, so let's suppose this is website A, website B, and website C. Okay. Now, what Google needs to do is it needs to establish, based on the search that you've put into its box, which of these web pages should appear at the top of that page. In other words, which is the most relevant. Okay, this is how it does it. It counts the number of links between web pages. Okay, so let's suppose you typed in the word cat. Okay, so you wanted to return a web page which had cats on. Okay, what it does is it scours these 3 web pages and it looks for the word cat. Okay, but not only does it look for the word cat, it also looks for links between the web pages. So let's suppose, for example, there is a web link, so you go onto website A, and it has a link which you can click on, which will take you to website B, okay? And in fact, let's not suppose that there is just one link, let's suppose there's 5 links, okay? So 5 different links that takes you from website A to website B, okay? Let's carry on then. Let's suppose that there are 2 links which take you from website A to website C, okay? So I could represent that like this. So website A will link to website B using 5 links, and it will link to website C using 2 links, okay? Okay, let's have a look at website B then. Let's suppose that B links to C using just 1 link, but it doesn't bother linking back to A. So there's no link on website B that will take you back to website A, okay? And then finally, let's have a look at website C. Well, all right, let's suppose that website C has 10 links to website B, okay? And let's suppose that there are 3 links to website A, okay? So what we have here is something called a network, okay? It's a network. In fact, if I wanted to generalize this using mathematical language, what we have here is a graph, okay? Because a graph is just a way of connecting points. Okay, so if you ever looked at graph theory, there's a whole branch of mathematics called graph theory. I did it in my final year. This is what this is all about. It's about nodes and edges. Okay, so how can I take this, which is a bit of a mess? You can imagine this is just with 3 websites. Imagine Google, which looks at, say, 10,000 or 1 million websites. It's going to have something that looks like this. How can I express this to understand what is happening? I can use a matrix. So this is how it's going to work. I'm going to create a matrix. Along here are going to be my 3 websites. So what have I got? I've got A, B, and C. So it's going to be A, B, and C. And if you like, this is the starting point of my web page. Okay, so for example, this link here starts at A and goes to B. So my starting point is on this side, okay, and my finishing point will be the columns. So my rows are starting points, my columns are where those links end up. So let's go through and let's fill in this, what's going on here. Are there any websites where, let's have a look at this element then. So this basically says how many links are there that links A back to itself. Well, if I look at my network, there are no links which link A back to itself. Does that make sense? There's nowhere on A that links it to another point in that web page. So there's nothing there. So I put a 0 there. Okay. This element here would represent a link starting at A and going to B. Well, are there any links which start at A and go to B? Yeah, there's 5. That's what that one is there, right? So I can put a 5 there. Okay. This element here would represent a link which starts at A and goes to C. Well, are there any links which start at A and go to C? Yeah, there's 2. So I'd put a 2 there. Okay. What number would go here? So this represents a link which starts at B and goes to A. There's 0. There's no link that does that. What element goes here? So this is a link that starts at B and goes to B. 0. There's no links which link B to itself. How many links start at B and go to C? Just 1. How many links start at C and go to A? 3. Is that one there? How many links start at C and go to B? 10. Is that one there? And how many links start at C and go to C? So can you see that just by considering web pages and the links, you can start to see which website is the most prominent? In fact, looking at this, which one would be the most prominent? I haven't asked you to do any row operations here. Which one would you say is the most prominent? Sorry? Yeah, so C or B. So which one do you reckon? I reckon it's going to be B. I reckon B, I would put that at the top of my search page because it has the most links going to it. If you think about it, it has 15 links in total. Do you see that? It has 15 links in total linking to it. Okay, and I can see that from this matrix if I do row operations on it. In fact, it's just a fancy way of doing matrix multiplication. Okay, this website C only has 3 links linking to it, and this website A only has 3 links linking to it. So I would put B at the top of my search page because that has the most links to it. In other words, it's probably the most popular page. Okay. Now I've just done this in terms of Google. This will always work in terms of Facebook. So when it's suggesting you friends, it could do it like this. It says, look, this person has loads of friends and it has loads of friends in common with your friends. So I think I should suggest this person to be a friend of yours. YouTube, for example, you see those recommended things in YouTube. This would work in the same way. This is a website this is one that lots of people with the same interests of you have used. I mean, networks and graphs are really, really big in maths, particularly with the age of big data. Okay, so nowadays we're being told there's lots of data being collected about us. How do we process it? It's using networks and graphs, which then laid directly into matrices. Okay, so don't just think matrices are tables of numbers, which is what I've been telling you. Also see how useful they are. Okay.